Welcome to the Bright Insight podcast. This is a weekly show provided by Brightside Security Lab. We're talking about updates on security regulations, requirements, and perspectives on the current cybersecurity developments. Security is becoming more widely used and important at home, work, school, or in your personal life. Think about GDPR and the Cybersecurity Act. Cybersecurity is a shared responsibility. The more systems we secure, the more secure we all are. Thank you for listening to Bright Insight.
Thank you, John, for joining us. Thank you for being here today.
No problem.
Today, we are having this podcast and we were talking about certification and what is the state of the certification. And I know you guys, you're doing a lot of certifications. You, on top of it, you have presence globally. So I'm pretty sure you have some experience to share with us about what's happening in the world of certification. And then probably later we can talk more specifically about Europe. But hey, John, do you mind introducing yourself to the audience for some people, because probably there is somebody who is not familiar with you, although a lot of people know you already. Please go ahead and introduce yourself.
My name is John Boggie, and I am the head of Cybersecurity Certification for NXP Semiconductors. NXP Semiconductors is one of the largest microcontroller manufacturers in the world. We are the biggest in Europe, and I'm also vice president of Eurosmart with a permanent seat on the board, and I am the chairman of Charter of Trust Principle 7, which relates to certification of critical infrastructure.
Thanks, John. And let's start with that. Tell us a little bit about your role. What do you do in this role as the head of security certifications?
Yeah, so basically I try to make sure that when the NXP products are released or launched, that they have the security certification or the security proof that they require to sell in the marketplace, depending on what that sector is, or horizontal, vertical, as the terminology goes. I run a team of 30 plus people, probably more closer to 40, and we work on certification standards around the world. So we have a team in China, we have a team in the US, and most of our presence in Europe. And we tend to concentrate in Europe because a lot of the thought leadership around security certification happens in Europe. And you can see that with the development of things like the Radio Equipment Directive and the Cybersecurity Act within Europe. And really that's it. We're making sure that our products, our processes and everything have the certification that's required. And we take a very holistic approach on that. So certification tends to fall into three categories. There's the information security management systems, things like ISO 27001. There's secure development processes, which is IEC 62443, 21434 in automotive, and probably what most people think about, which is product certifications, for example, common criteria, PSA, CSIP, all of these things, FIPS. And what we try to do is we try to cover all of this. And the reason why we do that is because if you have information security management and you have a secure development process certified, it shows that you're a trusted supplier, and that you can contribute to a trusted supply chain. And by having secure development processes plus the certification proof of the claims that we make on the product, you can also show that you have the idea of security by design covered.
Now you mentioned a few standards, and also in your introduction you talk about a wide range of products. Do you see difference among those different product categories? I mean, from products which are in the traditional security domain, high level of assurance, versus other products that they are more in the emerging technologies, emerging markets. How different are the requirements? How different are the schemes? Are there major differences? And then on top of it, do you see also those differences globally? Because it's not just Europe, right? So you work in a global space. How much alignment, how much difference is among all of them?
I think in the mature marketplace, so if you think about things like secure elements, which are traditionally thought as the high security products, and the reason why they're high secure is because they are doing things like protecting the banking system. They are protecting, for example, international borders. Now, when you get to the emerging markets, so when you go more into the consumer IoT, there isn't this drive to have these high security products because, at the end of the day, it's maybe a speaker or it's your fridge, and with those products, what can happen? Maybe they steal your Wi-Fi code, or maybe they order too much milk or whatever. There's not really this concept that they need the high security. And that tends to end up with somebody bolting security on as an afterthought. And the certification schemes there are a little more basic. So it's a little more the understanding of, do you have security? Yes, we do. Can you prove it?
And in your view, what would be the major difference in the approach, or is there any major difference in the approach to security between different regions? For example, in Europe, we are talking about common criteria being very popular in general. I guess that's the fact for traditional markets. But then in the US, you have things like FIPS. How different are those requirements, and how much is the approach different from one to another?
Well, as I said before, I mean, it's difficult to. It's a little bit like chalk and cheese there, because FIPS is a very specific requirement. It's a cryptographic module, so it's there to do crypto operations, authentication, whatever, and it's very much focused on that. So have you developed the crypto correctly? If somebody accesses my module, can you erase all of the keys and make sure it's protected? And that's really where the focus is with FIPS. Common criteria for me is more of a Lego. So there's lots of different functional requirements there, and you can choose depending on what product or technology you have, you can choose some of those building blocks and then test it. There is also this concept within common criteria around the vulnerability assessment. And the vulnerability assessment really has this focus on how much time has somebody spent trying to hack this product. And I think that's the biggest difference between something like FIPS, where it's more that case of, do you have something? Is it there? Does it work? Whereas common criteria, when you go to the higher levels, it's more, how much time are you allowing me to break this product?
Also, something that is changing here is our definition of product, right? Because in the past, a product was this monolithic idea element that was closed, but nowadays we realize that actually there is no one product. Inside of every product, you have multiple products, multiple developers, and each of those components can be also updated independently, affecting the overall security of the device, right?
Yeah, exactly. And we always talk in microcontrollers about things like root of trust, where we say, you have this centralized control unit that protects the rest of the system. And even that as a concept is a little, I wouldn't use the word stupid, but it's a little naive, that, you have one component that controls the security of everything. For a start, I mean, you would have to have a very powerful computer as the root of trust there, because it has to process a huge amount of data, and it has to protect a huge amount of data. So more and more we will see distributed security within a product or within a device. And if you look at something like a car, an automotive product, that's already happening. There's various domains within a car which are kind of working together, and because of that, you also it's like virus. It's difficult in these days not to go back to COVID and to viruses, but it's a similar concept as that. What happens when something becomes infected? You want the rest of the system to isolate that, and then bring in your antibodies or whatever to attack it, or to ask for getting back to technology and an OS update or something there, or a patch. And that's also how we have to think about systems. And as you said about supply chains as well, if you look at an automotive product, a car, it has millions of lines of code. It has thousands and thousands of components. It'll have security components and amongst that, and those components will be coming from different vendors. So you won't have. I mean, I would love it that NXP was every single chip in the car was NXP, but unfortunately, it's not the case. There's lots of other vendors there. So even when you think about dropping in new operating systems because you've hit a security issue, who owns what and who has access to which part of the product is really complex and really, really difficult. And that's for me also why the holistic approach with certifications. So making sure that you have good security concepts in a company, they have good security processes and procedures, and also that if they've made a claim about a product that it's tested and verified. I think probably that will happen in sampling rather than having every single product be certified. I think there'll probably be a sampling from the process. And I think that's the way it'll move forward. I think on systems, there'll probably be intermediate pen testing campaigns on the systems to ensure that it's still secure, or it's still, protecting itself against current state-of-the-art attacks.
Yeah, and is this also this idea that systems are getting more complex? So we're talking about device security, we talk about system security, but since most of our economy is driven by services, everything that we're discussing right now will have a direct impact in those services, and therefore security of devices and processes, and at the end of the day will result on security of the services, which what we are going to be using every day.
Exactly, and I think we're security people, and we're always saying we need to add security, and we're paranoid about attacks, but we are right to be paranoid. The amount of data that the average person now gives freely into the cloud that can be analyzed and parsed and whatever is mind blowing. I mean, even just doing you used to do a Google search on yourself and see what came up, but the amount of data that you can find about somebody, and even when somebody posts something on Facebook or on Twitter, you tend to go backwards and find out where are they from. You can see what car they've driven, you can see their kids, you can see their house. You've got a good understanding of where they are. And
there's no undo option, right? Once the data is out there, that's it. You cannot revert it.
It's once it's written, and it's there, in some cache somewhere. And us as citizens of the world, we want to make sure that our data is secure. We don't want to be, going to the cache machine one day and discovering all of our cache is gone, and there's no way to get it back because somebody has erased all of the data there. And I think also, if you look at the way things are connected, we see more and more state-sponsored attack on infrastructure. I mean, we had one recently, a denial of service in Scotland, which cost an NGO a lot of time and money, and so we have to get this right, because the more we connect up, the more opportunity there is, the more opportunity for crime, and also for cyber wars, which are happening at the moment, or happening behind the curtains and behind proxies.
How much the maturity of developers have to do with this? Because of course, if the developer knows what they're doing, they understand best practices, they have security hygiene, etc., they should reduce the risk. But the fact is, how many of those developers are ready to do something like that?
I think most developers know that they have to add security. The problem is that security for so long has been seen as a bolt-on, and for me, it fundamentally starts at university, because at university, security is seen as a module. You add a module onto your course, and yet something like functionality. So when somebody is designing or developing or coding, they'll have a specification that they design or develop to, and that will have some sort of operating window that they need to have the system working in.
And as in engineers, we are told to make algorithms efficient, which often translate in insecure.
Exactly, and this is the old thing that you as a lab see time and time again, where somebody I've added security, and then they go, the compiler compiled it out.
Making efficient codes.
Yeah, exactly. It's why are you checking this twice? You don't need to do that. You only need to do it once. And really that's where we have to start again. We have to think about the next level, the next generation of engineers, and really the whole idea of security as part of the system. So it's not only defining a window for operation, it's also making sure that this system stays in that window, and when it starts to move out of that window of operation, how do you pull it back in to running safely again?
That sounds like a good point to start. Going back to the basics, going back to our future generation of engineers, and then only then we will be looking to address this security by design we kept talking about, right? When this is already embedded in our education system for the future engineers of this world.
Yeah.
Thank you, John. Thank you very much.
Thank you for listening to Bright Insight. In the next episodes, we will cover different topics, such as the EU Cybersecurity Act, the business case of security evaluations, common criteria, SASIP, IoT, and software-based security. Stay tuned and subscribe on brightside.com.